We'll start our first problem, that is in CPU scheduling. In CPU scheduling, I told you we have got four types of problems, scheduling algorithms. Under that, first one is a FCFS, first come first served algorithm. So here I have written first come first served algorithm is a non-preemptive. By default it is a non-preemptive. We cannot make of a FCFS in a preemptive way. Okay, so we'll see what is this FCM. I have explained this FCFS complete theoretical part in a Zoom classes. See, it is going to schedule the process in a first come first way order. The process which is coming in a first, it is going to be served first. So you can consider this problem which I have given here. Consider the following set of processes that arrive at time 0. In the question itself he has given the processes are coming at the time 0 with the length of the CPU burst given in a millisecond. So that is, the burst is nothing but the service time required by the process, means how many minutes it is going to execute in the CPU. That is known as a burst time. Okay, so in the table you can just see P stands for processes, P1, P2, P3, P1 process, P2 process, P3 process. AT stands for arrival time, BT stands for burst time. So this is the given data and he has asked to find out average waiting time of a processes. Means we need to find out the average waiting time of a process. Okay, so you can just observe in the question he has given the arrival time as a 0. So that is why I have taken all the process coming at the time interval 0. So you can just assume this as a, for example, coming at 1 o'clock, coming at 2 o'clock. So in the same way here processes are coming at the time 0 in the starting time itself. Always the CPU is going to start from the 0 millisecond. So that is why at the beginning itself all the processes have arrived. So in this case, who is the first come process? So in this type of problems, when the arrival time is same for all the process, you are going to consider the process which is there in the first in a order. Means in the table process P1 is the first one, so that is why you are going to choose process P1 to schedule. So we'll see how to schedule this one. So I'll write this part. So that is solution. See, I'm going to write the Gantt chart. We are going to term it as a Gantt chart to draw a scheduling of the processes. Okay, so first you need to draw like this. See, just I have written a box and write 0 here. Why? Because you consider this box as a CPU. Okay, so I need to dump all this process that is present over here to here in the CPU part. Okay, so I am going to consider process P1 for the execution at time interval 0. Why? Because all the process are in the same time 0 0 0. So first come first served anta helidini. So but here all the process are in a same time. So table contains the order that is a P1 in a first one. So that is why I am going to schedule P1. Okay, so P1 process I am going to schedule since he is in the first place in the table. Okay, so he will be having how many milliseconds? 24 milliseconds he may need. Okay, if it is 1 millisecond, I'll put a small box here. So if it is 2 milliseconds, I'll go for next place and so on. So I may just randomly I'll choose 24 milliseconds somewhere here. Okay, ಸ್ವಲ್ಪ ಅಂದರೆ 24 ಮಿಲಿಸೆಕೆಂಡ್ ಅಂದರೆ ಒಂದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಸ್ಪೇಸ್ ತೊಗೊಂಡಿನಿ ಅಷ್ಟೇ. 1 ಮಿಲಿಸೆಕೆಂಡ್ಸ್ ಆದರೆ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ತೊಗೊಳ್ತಾ ಇದ್ದೆ ಇನ್ ದ ಸೇಮ್ ವೇ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಇಟ್ ಕಂಪ್ಲೀಟೆಡ್ P1 process, it enters to a CPU scheduling and it completed the task. Okay, so I told you it is a non-preemptive, means you cannot preempt any other process who is going to come here. Means you cannot allot P2 in between here, P3 in between here. Since this process is a P1 process is a first come first served, so it is going to be completed first. And then I am going to allot which process in the table. P2 is there. I am going to allocate P2. He is having 3 milliseconds burst time. So 24 milliseconds already over. 24 plus 3, that is burst time of the process 2 is 3 milliseconds. 24 plus 3 is 27 milliseconds. Okay, in the same way, so now process P2 completed the task. Now another process P3 is there, that is E again needs 3 milliseconds. So 3 milliseconds means I'll again draw some line here. So here P3 process, okay, with the time 30, so that is 27 plus 3 is 30 milliseconds. Okay, the Gantt chart drawing is over. This is the main part of the ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಗ್ಯಾನ್ ಚಾರ್ಟ್ ಬರೆಯೋದೇ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟು. ಸೊ ಇದು ಯಾವ ಥರ ಬರದೆ ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಅನ್ಕೊತೀನಿ. ಸೊ ಪ್ರಾಸೆಸ್ P1 is there. So process P1, it is there in a first place in the table. Okay, so that is why I scheduled the process P1. So next it is a process P2. So that is why I scheduled P2, P3, P3. Okay, so since the arrival time is same for all the process, so in these kinds of situation you need to select the process who is there in a first position in the table. ಓಕೆ, ಸೊ ಎಲ್ಲ ಪ್ರಾಸೆಸ್ಗೂ ಒಂದೇ ಅರೈವಲ್ ಟೈಮ್ ಇದ್ದಾಗ ನಾವು ಟೇಬಲಲ್ಲಿ ಯಾವ ಪ್ರಾಸೆಸ್ ಫಸ್ಟ್ ಇರುತ್ತೋ ಅದನ್ನು ಶೆಡ್ಯೂಲ್ ಮಾಡಬೇಕು. ಅದ್ರ ನೆಕ್ಸ್ಟ್ ಯಾರಿರ್ತಾರೆ ಅವರು, ಅದ್ರ ನೆಕ್ಸ್ಟ್ ಯಾರಿರ್ತಾರೆ ಅವರು, ಈ ಥರ ಶೆಡ್ಯೂಲಿಂಗ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಇದು ಗ್ಯಾನ್ ಚಾರ್ಟ್ ಕಂಪ್ಲೀಟ್ ಆಯಿತು. ಓಕೆ, ಇದನ್ನು ನೋಡಿಕೊಂಡು ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ waiting time and the completion time. Okay, so you write the same data here again. Okay, that is a process P1, P2, P3. Okay, and the arrival time he has given 0, 0, 0, and he has given burst time. Okay, so that is 24, 3, 3. Okay, and I need to find out completion time. Completion time means at what time the process completed its task. See, process P1 entered the CPU execution at 0 millisecond and he completed at 24 millisecond. Soon after completing, he exited, means he terminated. So process P1 completed at 24 milliseconds. Okay, in the same way process P2 completed at 27 millisecond. In the same way process P3 completed at 30 millisecond. Okay, so that is about the completion time. CT is a completion time. Next I am going to find out TAT, that is turn around time. Okay, turn around time is nothing but the burst time and the waiting time. Turn around time is nothing but turnaround time is equal to waiting time plus burst time. Okay, so when the process enters to a CPU, it may wait, okay, and it is going to execute. Two things it can do. One thing it can wait, one thing it can execute. So that is why turnaround time of a process is waiting plus burst time. Okay, burst time andre it is going to be in a execution state, otherwise it will be in a waiting state, otherwise it is going to be terminated. So that is why terminated. Okay, TAT. Okay, how to find out the TAT? So TAT, you are going to take a TAT as a, that is nothing but you are going to minus the, so you are going to minus the CT, that is TAT. You can write TAT as a CT minus 80, another one. Okay, so CT minus 80. So here I am going to do CT is equal to CT minus 80. Okay, completion time minus arrival time. Completion time of process P1 is 24. Arrival time of process P1 is 0. 24 minus 0 is 24. Same way 27 minus 0 is 27. 30 minus 0 is 30. That is you are going to get turnaround time. Next you are going to calculate what? Waiting time. This one. Waiting time. Okay, so here waiting time formula. So that is TAT minus burst time. Okay, so TAT minus burst time means, TAT means this one 24, burst time means this one 24. Okay, 24 minus 24 is 0. Again 27 minus 3 is, that is how much? 24. Okay, in the same way you are going to perform for process 3. You are going to get 27. Okay, so 30 minus 3 is 27. 27 minus 3 is 24. You got waiting time 0, 24. You just focus on the formula which I have written. Okay, so you just concentrate on this formula. TAT, in order to find out the TAT, you need to write CT minus AT. Okay, for finding out the WT, that is the waiting time, TAT minus BT, that is turnaround time minus burst time. Okay, so that you need to ensure AT will be given in the problem itself, BT is also given in the problem itself. You need to find out from CT, TAT and WT. Okay, CT is nothing but the completion time. Okay, so completion time means at what time the process completed, and turnaround time means, so you need to apply formula. Waiting time andru kuda you need to apply the formula. But the question is to find out average waiting time. So you have written the waiting time of individual process. You can just see process P1 is 0. You can just observe in the cross check in the Gantt chart. Process P1, it didn't wait for milliseconds also. He arrived at the 0 millisecond, right? He scheduled at the 0 milliseconds. He didn't even wait also. So that is why it is 0 milliseconds. Correct, Aitalva? So in the same way, process P2, the waiting time is 24. Is telling that process P2 waited up to 24 milliseconds. We'll cross verify in the Gantt chart. You can just see process P2, it started execution at 24 milliseconds, means soon after completion of the process P1. But the process P2 arrived at how many milliseconds? 0 milliseconds. So you can just analyze now. So process P2 waited until the process P1 completed, that is up to 24 milliseconds he waited. Now this is also correct now, cross verification. And then we got 27 milliseconds waiting time for the process P3. So we'll cross verify this also. So you can just see process P3 arrived at 0 millisecond and it waited until the process P1 and P2 completed their task. So that is 27 milliseconds. How I got these two? So process P1 burst time is 24. I have written process P2 burst time is 3. That is 24 plus 3 is 27. In the same way, 27 plus 3 is 30. Okay, that completes. We'll find out the average now. So that is average waiting time is equal to 0 plus 24 plus 27 divided by how many process? 3 process. So divided by 3. So how much you are going to get? 17 milliseconds. That is the answer. Okay. So this is a complete problem. That is a Fcfs. Okay. When all the process is having the same arrival time. Okay.